Hello.
Ma'am said you are so energetic, but you are not even growing like anything. Just glow, fine. Speak up. Hi. Hello. Great. Yes, you are right, ma'am. Am I audible? Yes. First of all, I need to start. Oh, it's my privilege to have this stage. Thank you so much for you. And first of all, I'll start with a normal funny note. How many of you know Telugu here? Raise your hands. Even I know. How many of you know Hindi? Great. How many of you know
Arabic.
Tamil? How many of you know Verilog? See, even I raised half of my hand. I didn't raise completely. So we are learning. So it's nice, it's great to speak with you guys. Our main agenda today is to open some perspectives against about the VLSI industry. We are having some of my folks who already worked, who already experienced candidates. So the flow of this meeting will be, first, my folk will come and explain about the Verilog and the strength of Verilog and what can you achieve from the Verilog. And since then, the circuit will be started of experiences of the folks. I'm inviting Mohan to give some explorations against about the Verilog skills. What do you want to learn? Just come.
Hello guys. Almost you are the seniors for me. Okay, I am just joined as an MTech fresher, and previously I worked in its MNC company as a full stack developer for 3 years. Okay, later that I came to VLSI. Why, what made me to choose VLSI? Everything I'm going to tell, and I'm going to show a processor, how to design a processor and everything. It will be interesting. At last you need to see the surprise, how I designed that one, on what basis I have designed that one. Okay, let's start the session. It's visible, right? Everyone. Yes. Okay. Ma'am told like the chips are made from silicon. Okay. Then where is RTL coming into picture? Why we need to learn Verilog? Why are you learning digital electronics? Okay. Most of the chips, like suppose if you see the latest processor, which the Snapdragon has released, Qualcomm, that 8G, which was boosting everything. Apple Bionic chips, everything on swap now. So even Apple is coming into picture the next era, but till now the Qualcomm was the topmost one, the Snapdragon one. But here issue was why we need to learn digital electronics. Why you need to learn Verilog? Because the VLSI chip designing process is a hectic one. If one flaw in the chip makes you to go back into so many years of work, you need to go. So many engineers keep their step-by-step process and they will do a lot of things in that one. So even a small mistake in the area, power or time, they will lose the everything and they will need to do again from the scratch. So in VLSI also they will see only 3 parts they will tell mostly: area, power and time. Why these 3? Why can't they go for other parameters? Suppose if you take your smartphone. Previously the smartphone was somewhat big. Okay, now they were very slim. And second thing, if you want to open an application, it should be open at a time, at a glance. It should not hang. And second thing, if you charge your phone, it should be capable of holding its battery. That means power, timing, and area. These 3 are the most important parameters for any chip or any application or anything. So if you design a chip, it will be the heart of the processor. Like if my phone is there, if I remove that SoC, it won't be working anything. That is the brain, that is the heart, everything. That main processing unit of entire applications, which you have seen till now. So now we are going to meet my processor. This is my BTech project. So how I design, I am not going in depth of everything. Whatever you learn, like you know digital electronics, you know Verilog. So based on that only, I am going to explain this structure. So if you are not able to understand this process, you are, on the coming semesters you're going to learn these things. Okay? It was like there will be two steps, ASIC and FPGA flows. Two things will be there in the mostly in the FPGA flow, in the VLSI flow. Suppose ASIC means it is a specific application oriented kind of thing. If you design for mobile application, it will work for mobile only. It won't work for any other types. FPGA boards can implement universal logics. So, like if you want to design a product in VLSI, first of all you need to be thorough with your functionality. So we need to write a code in Verilog, and we need to simulate in FPGA so that we can prove like it is functionally okay. Whatever the task you have given, my chip is going to execute that one. You are practically proving that one without fabricating it. Second, after RTL means register transfer level, okay, logic or level, anything. So if you code that one in the register transfer level, this code will be taken and designed into binary form, like basic, like if you code something, you are coding in module and module you are putting, right? How the computer is going to execute that one? It is turning that entire level of logic into basic gates. That is called netlist. Synthesis, ma'am told, right? Synthesis, we need to synthesize the circuits and everything. So the synthesis report is used for generating area, power and time. That is, we will use another tool. Two tools. All these tools, what I am telling is, that are there in the VIT. Okay, in my previous college, we have only 5 systems of cadence. But for that, we need to stay up to 11 o'clock in the night and morning 8 o'clock. Like, even BTech also I tried like a school kind of thing it was. Here you have, simply you can sit in your hostel and you can utilize all your resources. So, the best part you have, the best weapon you have is your second year, second semester people. So you have 4 more semesters. If you work hard, you can able to crack entire, you are equivalent to us. Much more equivalent to us. You have far benefit, you have time, you have resources, you have faculty members. Only thing is you need to put efforts. That's it. Okay, let's move into a processor. Like usually processor consists of 2 architectures, RISC and CISC. RISC means reduced instruction set architecture and CISC means complex instruction set architecture. Those things you need to go and learn in the coming semesters. Like I will simply tell a glimpse kind of thing. Suppose your phone is there. If you see your laptop, 64-bit, 32-bit processor, 64-bit processor means every instruction is, that length is same. Means if every instruction length is same, then it is called reduced instruction set. Means we are designing a block basically to the 64-bit. It is not 128-bit, it is not a complex kind of thing. But complex structures are for specific applications, like satellite applications might be used, may not be used. It's dependable because RISC architecture is somewhat faster, it is energy efficient for practical purpose. Means our mobiles, everything will be depending on only time purpose, power, everything. So we will usually go for RISC architectures. But CISC, if you design a CISC architecture, you are much more better. That's what I'm saying. This was the architecture I built in my BTech processor. See, you can see there, like ALUs are there, MUX are there, shift registers. If you combine all these blocks, you can able to get some functionality. My processor is a 5-stage processor, and it is a 32-bit RISC architecture processor. So that means it will take an instruction, it will fetch it, decode, execute, and whatever the result, it will store it in the memory and give it back to the register again. Suppose, how many of you know 8086 processor? Okay, so many. Suppose the people who don't know, right, I will tell like a small glimpse kind of. It is a microprocessor, 8086, 808. Now, if you have given some command to it, usually there was a lab for us in our BTech. Like we need to code it in assembly level language. It will show some traffic light controller or step-out motor or something it will show. I will also show the same codes with this processor. I will change the codes, everything, memory data. It's a hand-on experience kind of thing. In the Verilog, I will change the data. I will push the data, everything, assembly language codes. You can able to see the output also. Same, it is similar to that same 8086 processor. Here, suppose any task you have gone to some company, or otherwise you have gone to an internship, they will give you, usually in VLSI companies there won't be any internet access, first of all, because they will suppose it's a prestige issue, right? Because if the chip gone out now, before publishing itself, the patent will be gone. So they won't allow any internet access, mostly small startup companies I'm telling you, not Intel or something. Okay, they will have intranet access. So intranet access means they will have some files. By that you can able to solve the questions. And second foremost thing is in the VLS interview kind of thing, right? They will see, they will give a question, they will give hints, they will observe the kind of thing like whether you are solving the question or you are leaving the, like I will go for next question. They will observe the things because when you go to office, right, it will be different kind of scenario. It will be like nobody will help you. Think it like that only. Okay. If somebody help now, it's okay, fine. But if you prepare like that and if you work hard from now itself, it will be easy for you, nothing. And here my processor is going to execute 3 types of instructions. It is R type, J type and I type. It's not recommended. Simply think it like some processor is there, it is going to implement 3 instructions. Each instruction is of 32 bit. Okay. This R type is fabricate like this. This was the structure of R type. Like first one is the source register, destination, another register, and third one is the destination register. Suppose 2 operands are there, it is storing in some other operator, operand something. That means what? It is addition, multiplication, division, or modulus or something like that. Means arithmetic operations mostly. Suppose this means all arithmetical and logical operations are done by this instruction. These are stored in this instruction. And each instruction adds of mul is consisting of some opcodes. Suppose 000, it will do some operation. 001, it will do some operation. For better application, I will tell, your calculator is there. You are entering 2 values. If you press plus symbol, you are getting addition. If you press minus, you are getting subtraction. You are getting, if you put asterisk, you are getting multiplication output. How it is coming? Means it is taking 2 inputs. Every circuit is already there itself. You are selecting just the selection bits. Whatever the selection bit you are entering, it is acting as enable pin to that one and it is giving the output. Just normal circuit request. You can able to code that one using Verilog also. Normal, that same type of functionality, each and everything is an enable pins here. Like that, 2 sets. It's like jumping kind of thing. So by combining all this, we can able to do a factorial program or prime number, something we can do. Like this is the third statement, third instruction. See, till now you have seen 3 blocks, right? If you combine these 3 blocks, you will get a microprocessor. This name is MIPS. MIPS means I didn't tell you MIPS. MIPS means microprocessor without interlocking pipeline stages. Here, 2 acronyms will be there, millions of instructions per second. But according to my paper, I took a base paper actually. Based on my base paper, it was millions of instructions per second. Means some pipeline issue is there. Suppose 3 instructions are there parallelly. Okay, I will show you picture later. Suppose 3 instructions are there: fetching, decoding, execution, memory, and write back. We need to do 5 operations in 5 clock cycles. But when the 6th clock cycle came, I can able to get 2 instructions at a time. Like for the first clock cycle, it will take the fetching. For the second clock cycle, the first execution get decoded, but the second instruction get fetched. Parallelly, it will do everything, parallel processing. That's what you will do in multi-core processors. You have multi-core, right? Parallelism will be there everywhere. And we are shifting the processor into blocks kind of thing. That's why you have octa-core, some cores is there, right? If you see in your laptop properties, you will get octa-core or single core or everything will be there. Everything will have a minute points. Just search that one, you will able to get everything. But this architecture has a flaw. That's why I changed the architecture to this one. This was my updated one. So I made this one. It will run parallelly without any flaws. It will show every circuit, whatever the commands. I have shown 3 types of instructions, right? Whatever the combination of instructions I have given, it will show exactly the output. Yeah. This was the output of the previous circuit. So see how clumsy it is. You can't understand anything because in between peripheral outputs also there. So foremost thing is, while presenting anything, the waveform, the circuits, even though they don't know anything, it should not be clumsy. Once they see something, okay, some clock is there, some reset is there, this is the output they are getting. They should be able to understand these things. And see, this was my updated code. First one is factorial code. Second one is Fibonacci series code. Third one is GCD. So single processor can able to do multiple things. I have given 3 tasks to my processor. It is doing that one. We will see all these things practically. After that, this is the schematic of this processor. My processor I have completed right in Verilog. If you run that one schematic operation, you will get the circuit like this. This was the basic symbolic representation of the Verilog code. See, why we need synthesis? This was the synthesized output. See, this was the main block which was given for the robots to print on the chip. Based on this only, they will get a silicon area. Like SOC will be developed, right? On the chip, the circuit will be printed, everything. Based on this input, you get to get the output. This was my ma'am told like 180 nanometer. She worked on 350 nanometer kind of thing. I worked on 180, 90, and 45. Actually, what that means, that nanometer? Anybody knows?
Length of the channel.
That is the distance between the source and drain of a MOSFET. If you go into string, what will happen? There will be nothing. Even though you didn't have a power also, it will jump. That's why after 3 nanometer, they are going for quantum mechanics. They are going for quantum computing and everything. They change. Intel announced a thing like it is going to perform 0.18 angstroms. So we need to see how it is going to be. And this was the area of chips, number of processors, number of transistors, how many cells is there, like that normal block kind of thing. And later ma'am told like one transistor, they have connected everywhere. You have seen some city kind of thing, ma'am told like route map is there. You can also generate that one. This was the 180 nanometer, my microprocessor layout actually, 180 nanometer. All these things I didn't do. Basically, ma'am shown is full custom design. Means from transistor level, we need to design. But for microprocessors, people won't do like that. They will go for semi-custom flow or already standard cells will be there. They will take the standard cells and put it there itself. By the previous engineers or somebody did the process. The ALU blocks, memory blocks. Suppose I want to design a 64-bit microprocessor, 64-bit laptop kind of thing, CPU kind of thing. Already 64-bit is there, right? So the Intel will have some basic boundaries. I will just take that one, put it there. Like similarly, LT Spice you are doing. How MOSFET you will type now, you will get, right? Similar process. You will create a symbol kind of thing. You will put it there. Library files, user-defined primitives kind of thing. You will do that one. So basically, 90 nanometer will be somewhat 90 nanometer somewhat colorful it is. I don't know why it came like that. It came. 45 I didn't have pictures because this data I am showing is right. It is 4 years before. So whatever I have presenting here. And see, till now I have shown you the power processor, microprocessor and everything. Okay. All these things I designed from your curriculum actually. See, this is your digital logic design, right? These are the basic blocks you have studied, coding you have studied, behavioral coding. All those blocks only I have used and created this architecture. So your VIT is already designed the process. Just go with the flow. Read the things carefully. Because VLSI will put you there itself. Because I got 2 offers in my BTech. One is big MNC, another one is small startup, which is VLSI. Everybody, even I tried myself, like I worked so hard, evening, morning, 8 to even night, 11 o'clock at the things. But the MNC also promised me to give VLSI. So everybody told me to go for VLSI, that MNC company. Because they frightened me like if you put in bench, a bench will be there. No work was given. If you got selected for a company, if no work was given, then you will be put in a bench. Suppose if you put in a bench, then your career will be lost. Like that they frightened me. I don't know the solution, what to say and everything. So calmly I have gone there, I have studied there. And then I came to, one day my friend called me, after 1 year he called me regarding Verilog project. I solved that one, I don't know. Then I understand like, to be small and precise, it was like a long distance relationship for me. Like, I was working in HCL, is the company I got selected for the .NET full stack developer. In Chennai, near Navaluru is my branch. It was a long distance kind of thing. Like, my mind, everything was there in VLSI, but I physically present. That's it. Something was lacking in me. I was not happy, so I decided and applied for MS Masters. I wrote GRE, TOEFL, everything. I got 7 universities: Arizona State University, Portland State University, everything, top big universities. Everything was done. Loan was completed. I got a health issue, and my father also got some health issue. So I thought, something. Why should I go for a US? Why can't I stay here? By God's grace, I got a seat in VLSA and VIT, and now I'm here pursuing my VLSA happily. I'm very happy. So one thing I need to tell is, nobody guided me. I don't have tools. I don't have anything. Nothing. Like, I was from a village kind of thing background. So from here almost it will take 19 hours for me to reach my hometown. So that far. Okay. So nobody told me about VLSI from my side. Only me. To whom I can speak, to whom I can clarify doubts. Here you have your faculty. Everybody was PhD scholars. Tools were there. First and foremost thing, you have time. Please utilize the time and do some nice project. And the project, right, you need to go from starting to ending. You need to know thoroughly everything. Like when somebody asks you now, you should explain everything perfectly. Then you will be in the Intel or Qualcomm or AMD anywhere, because that's what they want. They won't teach anything. If you learn something and came here, they will pick you directly up. But VLSI is very much interesting in subject. Please choose this. At last, I will show them, because somebody.
How was the lecture, brothers? It's great, Mohan sir. And he is inspiring us also. Actually,